Okay, in this presentation, we're going to look at probability theory. So what we're going to do here is look at continuous random variables. And so essentially we have this continuous random variable x, and it has probability density function, which is usually denoted PDF. And just to remark, small f there, lowercase f, with a subscript, which actually should be capital X. It's just a bit hard to tell when it's handwritten, but that should be capital X and lowercase x here. Okay. So it is, the PDF actually is 1 over 2 theta, and it's in the range minus theta to theta. Okay, so the value of x is in this PDF is valid in the range from minus theta to theta. Okay, so what we have to do in this particular example is show that the cumulative distribution function of x is, which is also denoted CDF, is f of x. Now just remark it's capital F in this case, theta plus x over 2 theta, and again in that range. Okay, and deduce an expression for the probability of x greater than x. Okay, so what we're going to do here is, we evaluate it. Now correctly we actually should evaluate it from minus infinity to x, but between minus infinity and minus theta the integral is 0, so you can just sort of ignore that step. Okay, so the PDF is the probability density function is 2 theta, or 1 over 2 theta, du. So we're integrating with respect to u, so that the answer comes out as an x, or as a function of x. Okay, so in this step here, this is important, we actually integrate with respect to u. Okay, so let's just sort of carry that. It's a simple enough calculation actually. Okay, so the integral of 1 over 2 theta, it's essentially a constant, so it's u over 2 theta, and that's the definite integral, x and minus infinity. So we let x equal to u, and we let theta equal to u, subtract one from the other. I skipped a step here, but just for the sake of space, but I thought it was fairly easy. So when you x minus theta gives you x plus theta, or in other words, theta plus x, which is exactly what we are asked for. Okay, and again, just to specify, the range of values is minus theta to theta. Okay, so the second part of this question was asking us for the probability of x greater than x. Okay, it's simply the complement of that function there. So it's 1 minus theta plus x over 2 theta. Actually, let's just put that in brackets there just to make it a little bit clearer. Okay, so if we express 1 as 2 theta over 2 theta, we get 2 theta minus x, so theta minus x essentially. Okay, so that one's actually very straightforward. Okay, so that's the first question. The second question is a bit longer. Okay, so we have this continuous random variable x, and it has the probability density function given as follows. So the probability density function is c times 1 minus x squared, and it's in the range of values minus 1 to 1. Okay, so the first thing we have to do is show that c is 3 over 4. Sketch a graph of f of x. I'm not going to actually do that so much. I'm just going to sort of give you some pointers how to do that one, and let you work on that yourself. And then show that the cumulative distribution function of x, the CDF of x, is given by this expression here. Okay, very complicated looking expression. So yeah, that's the question there. Okay, so let's start off. Okay, just actually with regards to the CDF, it's actually this part here is the main bit of work. Okay, so let's go back down here now. So the integral is of the PDF from minus 1 to 1 should evaluate to be 1. Okay, so let's just that's the PDF. So let's just actually put in the PDF there. C times 1 minus x squared. We'll just take out c and evaluate 1 minus x squared, integrate that, and we get x times x cubed over 3, and the definite integral is minus 1 to 1. Okay, so when we work that out, so we just put c out altogether and just like multiply it at the end. So 1 minus 1 cubed over 3 is 1 minus 1 cubed, 1 minus 1 third, okay, which works out to be 2 thirds. Okay, For minus 1, we get minus 1 minus minus 1 cubed. Minus 1 cubed is minus 1. So we have minus 1 plus 1/3. Okay, altogether. So that's minus 1, and that'll actually evaluate to be plus 1/3. Altogether, that is minus 2/3. So we have minus 2/3 minus minus 2/3, which is 4 over 3. And when we multiply in C, we get 4C over 3. So if 4C over 3 is equal to 1, that means C is equal to 3/4. Okay, so that's just essentially a definite integral question. It's essentially just knowing these limits here to use them in that calculation there, and also that it should evaluate to 1. Okay. Okay. So I'm getting a bit sniffly here. I'm just going to blow my nose. Just pause it for a second. Okay. So the second part is a sketch of the PDF. Okay, and it's in the interval minus 1 to 1. So essentially, all I am going to do here is just pick out some values here, evaluate them. Now, I sort of know that this is going to be a quadratic. Okay, this is some sort of mathematical theory. Okay, but essentially what I'm going to do is pick out some points. Minus 1, minus 0.5, 0, plus 0.5, and 1. Okay. And because it's going to be symmetric, I'm only actually going to do it for the negative side. So minus 1, just evaluate the function there. We get 3/4 of 1 minus minus 1 squared, which is 1 minus 1, 0. Okay, so we have a 0 down here. The point is down here. 3/4 of, 0.5, minus 0.5 squared is 0.25. So we have 1 minus 0.25, which is 3/4. So 3/4 to 3/4 is 9/16ths, okay, or minus 0.625. So it's up here. Likewise, this one will be above here. And finally, at 0, 3/4 of 1 minus 0 is 3/4. So there we go. So that's just a sort of quick sketch of what it should look like. I'll probably go into way more detail there than I should have. It is a quadratic. That's all you need, really, okay? You could try out more points, but essentially it does help to remember it is a quadratic expression. Okay. So the next one is the the cumulative distribution function. So that's the expression there, how we calculate it. Okay, from minus infinity to x. And the integral is in terms of u, such that the answer comes out as x. Okay, just remember that. U is just some sort of temporary variable that we use, so it cancels itself out, and then the answer is left up. The answer will be left as x, which is what we want. Okay. Now, just as a remark, I actually sort of said this before. Between minus infinity and minus 1, the integral would be 0 because the PDF is 0. Because if you integrate 0, you just get 0. So you just ignore that part there. That's why we sort of skip to the main part here, which is from minus 1 to x, okay, 3/4, 1 minus u squared du. We've sort of seen this already, 1 minus u squared, we integrate that, we get u minus u cubed over 3. We did something similar with in the previous part of the question. The definite integrals are minus 1 to x, okay, so x minus x cubed over 3, we got that part there. Oh, let's put that into shot. X minus x cubed over 3. We've got that part there. Minus 1 cubed over 3. That works out very similar to the last time. That actually works out to be 2/3. If you just recall from the last exercise, that will work out to be 2/3. So, what we have here is as follows. 3/4 of x minus x cubed over 3 plus 2/3. What I'm going to do actually here is I'm just going to put in turn x into 3x over 3, such that this will cancel out with this, and this, and so we are left with 2 plus 3x minus x cubed over 4. Okay. Now, so that's the second part of what we're looking for. Now, I'm going to evaluate it at a couple of different points, this cumulative distribution function. Now, I wrote this down realizing I didn't need it. I evaluate at x equals 0, I get a half, which is actually unnecessary. It's just a nice little exercise, but it didn't really help me as much as I wrote down x equal to 0, and then remembered it's actually from 1 minus 1 to 1. Okay, so evaluate at x equal to minus 1. Okay, and we get 2 minus 3 plus 1 over 4. Okay, just to show you what I mean there. 2 plus 3 times minus 1 is 2 minus 3. Minus 3 cubed, minus 1 cubed, minus times the minus 1 cubed ends up to be plus 1. Okay, so we actually get 2 minus 3 plus 1 over 4 equal to 0. That's exactly what we were expecting. Evaluate at x equal to 1. Something similar. We get 2 plus 3 minus 1 over 4. 4 over 4 equals 1. So that means that for x greater than or equal to 1, f of x, the cumulative distribution function of x will equal to 1. Okay, so that gives us a very complete answer to our question. Just to actually sort of remind ourselves what we were looking for, show that the cumulative distribution function is that. So it's a very complete answer there. Okay, so that is probability theory. Okay, I'll leave it there.